Good afternoon, ladies and gentlemen. Welcome to the ICE technical meeting, the impact of climate change on Jakarta. This event is brought to you by the Institute of Civil Engineers, ICE. My name is Aji from ICE Student Chapter, Venus University, and it is a pleasure to act as your master ceremony in this event. Before we start, allow me to read the rundown of our event this evening. First, I will be reading the rules of the webinar. Second, there will be opening remarks by the chairman of ICE-Jakarta Local Association, Phil Woodmansey. Then we will have David Me to give some introduction of the speakers. After that, the event will be guided by Michael Doby as our moderator to start the presentation of Peter Letitre. The event will then continue with Q&A session. Ladies and gentlemen, for your own convenience, please put attention to the following rules. You can ask your questions for the speakers by pressing the raise hand feature located at the bottom of the screen. The question should be in English. You can raise your question after the presentation of the speaker. You can also raise your question from the Q&A feature located at the bottom of the screen if you prefer the moderator to read your questions. Now, I will like to invite the chairman of the ICE-Jakarta Local Association, Phil Woodmansey, to give his opening remarks. To Phil Woodmansey, the time is yours.
Okay, thank you. I think we're just about right. So welcome everyone. Believe it or not, tonight we're back in EP. We've got a high-tech hybrid presentation. I'm happy to say there's about 12 or 15 of us have made it to EP. I can assure those who are not able to make it tonight, everything is exactly the same as it was when we left over 2 years ago. It's all the chairs are in the same place and the faces are very, very similar. So it's It's good to be back. First of all, thank you to RIFA again. This has exceeded our expectations. Even again, we have us here live in EP. We've got David is in the UK, and everybody else is on Zoom, and we've got the MC sitting either at university or at home. So it really is a high-tech evening tonight, and so far it's been going really well. So this evening, we're going to have a look at climate change and flooding. Actually, when we put this together, we sort of realized afterwards that there was probably 2, if not 3 presentations worth in the title. So tonight, I understand Peter's going to focus more on the flooding side with a little bit of a discussion on climate change. But I think later in the year, we'll be able to run something that brings in a little bit more detail on the climate change. So I think that's enough from me. I'd like to hand over now to David May, to introduce our speaker.
Okay, thanks, Phil. I actually am just recovering from a bit of a cold, so I hope there's not too many coughing interruptions. I must say, since I've been working in Indonesia since 1978, and since the 1980s, I've been aware of the flood management and hydrodynamic flood simulation models carried out by Deltares in Indonesia. In 2006, I helped Chris Morris from the ADB set up a flood modeling project in Bandung, which was implemented by Deltares to a very high standard. Now, I have to say, Peter works for Deltares. Whilst discussing this project with Pak Padoni in Bappenas, he demonstrated the Deltares model of Jakarta. This was a truly impressive piece of work, which I expect we'll see some of it, with some 13 rivers flowing through Jakarta, numerous cross linkages and storage ponds, and it clearly shows areas in Jakarta susceptible to flooding. Presumably, this has been the basis for improving flood management in Jakarta. In 2017 to 2020, I worked on the flood management for ADB in the PU's 8th floor office, next door to the Deltares World Bank team, and had the pleasure of meeting Peter and his team. I also had a 6-week input helping to review and edit a 6-city flood assessment project for which Peter was the team leader. I think we are in for a very interesting talk about the capital city where we reside. I hope this will be of particular interest to the BINUS students who live and study here. Okay, so I'd like now to either hand back to Phil or to hand over to Peter.
Everybody, it's an exciting moment that we now have our first hybrid event where we have an audience here in the Eastern Province and we also have an audience on Zoom. We've been looking forward to this day because for 2 years now we've been stuck behind our computers, and part of the purpose of our meetings always is to get together. A few minor hiccups, but nothing big, nothing you can't solve. So I would like to say a special thanks to many people involved. Phil, for example, was very keen that we should get back here and start making our presentations, and I think that's helped push us along as well. And we're also very lucky that our team here that can organize the technology to make this work has done such a wonderful job. This is the very first one. I guess there may be a few lessons that are going to get learned from this. but so far it's really good that we can present this to people here and also to people all over the place. And of course, we know that David Mee is there in the UK. So this is a truly international event tonight. Now, Peter, I've only met Peter for the first time tonight, whereas Dave's known him for many years, but it's welcome you to our event, Peter. It's really nice that you can spend time to come and talk to us on what is a really important topic about flooding and associated problems in Jakarta. So Peter's expertise is in obviously water management, land management, and so on. I think I don't need to go into that in too much detail. I'll just say a couple of things though about Deltares, because up until now, Peter didn't realize that, in fact, I beat him to it. I joined Deltares before he did. But Deltares is made up of two organizations. There's a soil mechanics side and the hydraulic side. And I joined an organization called Laboratorium for Grondmechanica in 1981, which is also known as the Del Soil Mechanics Laboratory. And I remember I was taken on a trip to visit what was called the Delft Hydraulics Laboratory then, and seeing the models they had, which were most impressive, especially to a geotechnical engineer, because we do quite small testing, but the testing going on at Deltares, these were huge models, and it was a really impressive thing to see. Anyhow, that was a few years ago. Things have moved along, names have changed, but I think the expertise has only developed further. And I think what we're going to hear about tonight is what can be achieved, what can be done by looking into the problems that we face, especially when we have the concerns of the effect of climate change, rising water levels, floods, and so on. So, Peter, you are there. I'll hand over to you now. So we look very much forward to your presentation. And what we'll do at the end, there will be a chance for people to ask questions. If they've come through on the chat feature, I'll look at them first and leave them to you. I think it's but Peter, looking forward to this talk very much. Thank you.
Thank you very much. Now, can I see my screen now? Or okay. Thank you very much. Very good evening. I'm so happy that I can be here in Jakarta after 2 years of working from home behind my desk and computer. The first time in Indonesia this week. And like I was introduced, I worked for 4.5 years until May 2020, when the pandemic struck Jakarta. To avoid the lockdown of Jakarta, I went back to the Netherlands, and this is the first time I'm back. So, and I really enjoy being here. And to tell you a little bit about the work that we have been doing for the last 4.5 years on the National Capital Integrated Coastal Development Project, a project that we were involved with the Ministry of Public Works, but also many other ministries, and also with engineers from the Netherlands and engineers from South Korea. So there was a very big team. But I was heading a knowledge management component, which looked at several issues, such as the mitigation of the land subsidence in Jakarta, and also responsible for capacity development and courses, organizing several kinds of courses. So I will present you about the work that we did, the latest results of the strategy development that we did for NCICD, and I will also explain the limitations of it, in the sense that it will not solve all the issues, and also point to some issues that relate to climate change, or that compare the effects of other developments with climate change. So, to start with, I'm trying to get the next sheet. I will tell a little bit about Deltares. Deltares is a knowledge institute, it's not a company. So we are the national laboratory for everything that relates to deltas and sustainable living in deltas. So there are a few societal themes that are relevant for our work, like flood risks, but also water and soil, subsoil resources. So actually what to do against drought and how to manage groundwater, the delta infrastructure, all the geotechnical aspects that relate to the construction of big infrastructure, and ecosystems and environmental quality. A few examples of projects that we did during the last 30 years in Indonesia. Deltares was only established in 2008. Before it was called Delft Hydraulics, and we have been involved in big river basin studies, but also in flood risk mapping and urban resilience studies financed by World Bank and other institutions in Bandung and Jakarta and other cities. Integrated water resources management studies, building with nature, the big project in Denmark where we apply nature-based solutions to protect the north coast of Central Java against coastal erosion, and for example, optimization of reservoir management. And we develop and apply tools and software to tackle these Indonesia water issues. We have also been working very intensively with several knowledge institutes and our sister institute, PUS-AIR, which unfortunately no longer exists. It was based in Bandung. It was part of the Ministry of Public Works, but also with other Dutch knowledge institutes and Indonesian knowledge institutes, such as BMKG, BPPT, BIG, etc., where we worked on tools for water and climate in Indonesia. So with climate and climate change modeling, national mapping, drought early warning system, developing integrated water resources management instruments, and of course flood sea level predictions and national database systems. So to give you an idea on what we have been doing, and the knowledge management component that I was involved in looked at, for example, the mitigation of land subsidence. We developed a roadmap on land subsidence. I will come shortly during my presentation on that topic, but also we developed integrated polar system, what has to be done to solve the pluvial flooding issues in the lower-lying areas of North Jakarta, which are now situated several meters below mean sea level, where they were still above sea level 40 years ago. This is the team that was involved in these studies also. And also projects in Semarang, for example, to develop integrated solutions for the water problems in Semarang, the flooding issues, the subsidence issues, to do economic evaluations of the comparison of taking measures with doing nothing scenarios, where we involved the stakeholders in the planning of these measures. Well, now we are starting to look at the flooding issues of Jakarta. And it looks as if the flooding issues of Jakarta are only of very recent nature, but actually they're not. Jakarta has always been plagued by, even 400 years ago, there are descriptions already that Jakarta suffered from flooding. No surprise, of course, with 5 meters of rainfall falling in the mountains of Bogor. So you can imagine what will happen if these rainfall take several days, extended days, to fall above upstream areas of Jakarta. No surprise that Jakarta will suffer from these floods. So you see here several examples, recent examples, but also historic examples from these flooding. So the theory is it's nothing new, but let's look at how to solve it. Well, the first attempt to solve it was done in 1918. You see the yellow arrow pointing to the Western Banjir Canal. It's Banjir Canal Barat. It was implemented in 1918 by Van Breen, a Dutch engineer. You still see a remembrance close to the gate of Manggarai, where his flag is now hidden under a big, you have seen it. So this is the first measure to capture actually the upstream rivers and divert it through the Banjir Canal Barat to the sea. Then in 1973, there was actually the first master plan for drainage and flood control of Jakarta implemented by NEDECO, a consortium of Dutch companies headed by Professor Jan Kok. He later joined Delft University of Technology. And they developed an integrated concept consisting of polders, retention basins, and at that time, the retention basins could be emptied partly by pumps already, but mostly by gravity. So you see still in fluid, the water fluid, an old flap gate, which was constructed in that period, that when the tide was low, you could drain the retention basin at fluid, water fluid. But, well, we will see that since the 1970s, a lot has changed in Jakarta. But this is actually, and importantly, they also designed an Eastern Banjir Canal. So after the successful implementation of the Western Banjir Canal, their idea was already to build an Eastern Banjir Canal. But that canal, for whatever reason, the Indonesian government decided not to build that at that time. Well, but then, since then, we have seen some very serious flood events, especially in 2007. And that was a kind of, historic event, especially the rainfall events. There were actually two big flood events, one because of rainfall and the other because of coastal flooding. I will come into that, but you will see here the rainfall event in the 2nd of February 2007, with a very high rainfall event in the north of Jakarta, and the second day, a very intensive rainfall event in Bogor, in the upstream areas. So all the retention bases were already full when the second flood came from upstream, and this resulted, as you see in the flood map on 2007, in very extensive rainfall and floods in the north of Jakarta. Well, the Dutch were called to analyze what happened and how extreme this actually was. So this was the first time when our flood modeling models were actually used to simulate what actually happened in 2007. So by making the schematizations of all the rivers and all the land use patterns, and we actually made a simulation which shows you indeed that the flooding patterns are very similar to what actually happened. And so this was the basis for taking new measures. But a very important event also happened later, but based on these floods, already a few measures were proposed. First, to make a new connection of Cipinang, the Sunter Warang Kagung Cagung train, and also to actually now decide to finish the Eastern Banjir Canal, and also to optimize the Manggarai Gate, which proved to be well, an obstacle, and also make a connection between the Ciliwung and the Eastern Banjir Canal. So 2007 already was a reason to take some measures. And in 2010, incredible, after 3 years, an eastern bungee canal was ready. It's an enormous achievement. So if anybody doubts on the implementation capacity of the Indonesian government to construct this kind of enormous infrastructure, have no doubts, it is possible. And here you see that the Eastern Bungee Canal, proposed already in 1973 by Letitre, was actually implemented. But then, what happened? In 2007, you see left above the situation at Fluid, and the walls, the coastal protection walls of Fluid were completely overtopped. And we had a massive flooding event. Flood waters reached to the Plaza Indonesia so far. And based on that, the walls at Fluid were raised with 2 meters. And let's see what happened 10 years later. 10 years later, with 2 meters higher walls at Fluid, it was again overtopped by higher sea levels. So there was a big discussion going on, of course, but what is happening? Is sea level rise going that fast? No, it actually, one of our colleagues predicted the flood because he knew that a King's Peak, or a very high exceptional tidal level, would strike Jakarta, and he actually predicted the moment that the flood would take place. And that also convinced a lot of decision makers that another phenomenon was actually taking place in Jakarta. And that is land subsidence. You see here some results of the geodetic and the surveys and monitoring that took place at ITI Bandung, the group of Professor Hasanuddin and Heri Andreas. And in the left, you see the land subsidence since 1925, reaching up in special areas up to 3 to 4 meters, which actually means that the north of Jakarta, which was above sea level, is now several meters under sea level. And in 2014, 2015, still with rates of 10 to 12 centimeters a year. And in and of course in the south of Jakarta, it's almost well, almost zero, maybe 1 centimeter a year, not completely zero. But you see the enormous differences in land subsidence between the north and the south, and also remarkably in several areas in the north of Jakarta. So what could be the reason of that? And we also have other experiences from other cities where land subsidence is taking place. And so here you see, for example, the sea level rise, which is about 6 meters in Jakarta, compared with the land subsidence in several cities, including Japan. And you see the green line starting already in 1900, reaching up to 4 meters in Tokyo. But the very good news is that actually something happened why the land subsidence has stopped in Tokyo. And that is actually very good news. Because that means that there is a solution, apparently, but can be stopped. Jakarta, you see, it's almost going the same direction as Tokyo. This is, of course, an older picture already. And you see also other cases like Bangkok. So many coastal cities have this problem. Why? Well, the scenarios for the future were very cumbersome. because Haley Andreas predicted that if nothing would happen, it would continue and North Jakarta would sink another 5 meters until 2100. And if groundwater, because that was already the assumption that if we stop groundwater, that the subsidence could be limited to 1.5–2 meters. But let's see if everybody was that convinced if groundwater abstractions were the main reason for land subsidence to happen. Actually, we organized the first roundtable discussion in 2015 with experts from the United States, from Japan, from Tokyo, from Venice, which is suffering from land subsidence as well, and with high decision makers, the then governor of Jakarta, Governor Ahok, ministries, etc. And of course with a lot of professionals, professors from Indonesia, where we presented the problems of different countries, but also from Indonesia. And it was actually, well, everybody had its own explanation about the causes of subsidence in Jakarta, from reaching from the weight of the infrastructure to groundwater abstraction. Some people thought it was groundwater abstractions, others said it's tectonics, or it may be the oil and gas abstractions in the north coast of Jakarta. Actually, that also, if you look at the history of Tokyo, that also happened. But then somebody saw that in 1945, more or less, land subsidence also stopped in Tokyo. And they said, what could have happened there? Well, the industry was bombed. Tokyo was, there was nothing left, so groundwater abstractions also stopped. And actually that convinced the Japanese scientific society to actually believe that groundwater must play a role. Well, that actually proved later, because Japan, Tokyo, diminished the pumping, made sure that drinking water supply and water for the industry was available for the entire city, and that lighter building materials were used, and they also did a lot to improve the spatial planning of Japan. I will come back to that later. But that actually had a success. You see upstream, the groundwater level, the hydraulic heads were increasing, and finally the land subsidence stopped in Tokyo. So just in time, because Tokyo was at the point of needing a very big infrastructure measure in the Bay of Tokyo, a big flood protection wall, but that could be avoided. Well, what we did during the NCICD project was also to look at the situation in Jakarta. And for example, we looked at the places of occurrence of high rates of subsidence, which are in the east and in the west of Bekasi. And if you look at the land use maps, you see that there are high concentrations of industry in these areas. And that these areas, you see left down, do not have pipe water supply. So you see the areas of pipe water supply in Jakarta, the green and the brown areas. So it's actually a correlation between the occurrence of land subsidence and the lack of pipe water supply. So leaving no other alternative for industry than to pump groundwater from 200 to 300 meters. With no law enforcement and a lot of illegal wells. There are about 4,000 formal wells, but about 9,000 wells in total, so about 5,000 illegal wells, also abstracting groundwater from 200 to 300 meters. So we also had a look at, well, what could be the effect of taking some measures. So you see here some scenario analysis, and why you see a bundle of analysis. We presented these modeling, subsidence modeling results to the Society of Geotechnical Engineers. 20 professors were in our session with a lot of decision makers and international experts. And they all said, well, it might be that parameter, it might be that parameter, but can you do a sensitivity analysis of all these different geotechnical parameters? So we did. So that's why you see a bundle, but it all the trends are comparable. This is the scenario actually where you would stop groundwater abstractions completely, and where the hydraulic heads would well, go up, and there is a certain elastic component of subsidence. And this is a scenario that there will be a balance between abstraction and recharge. And the upper part is the do nothing scenario. So just continue to abstract groundwater. You will see that subsidence will continue with until 2100, with up to 6 meters in total. Fortunately, IT Bandung also did geodetical monitoring. For example, the DKI province of Jakarta stopped the groundwater abstractions for one of the ICE factories in Muara Baru, and they carefully monitored what happened. And you see that in the graph left under that the subsidence was already reduced with 8% in 5 to 6 years. So that is very continuous actually. This kind of modeling was only possible, of course, in a few locations where all the geological information and other parameters could be collected, where we had good geological descriptions to define these geotechnical parameters. But now let's look at the effect of land subsidence. If land subsidence, you saw the master plan of NEDECO, which still looked at well, the drainage of the retention, the emptying of the retention basins by gravity. But when subsidence continues, that is no longer possible anymore. So you need to build retention ponds and pumping stations. And if the further subsidence continues, the more drastic the measures you have to take. Here you see, for example, a scenario that subsidence is stopped by 2030, where the land reclamation areas that were still projected, 17 land reclamations, have been concessions in the 90s. So the idea was to build dikes around these land reclamations and use that as the coastal protection for Jakarta. But if subsidence would continue after 2030, that was one of the results of the Jakarta Coastal Defense Strategy. It's one of the first new strategies to look at the solving of the Jakarta issues, flooding issues. It was already clear that something had to be done to build an outer sea dike and to lower the level of the water in Jakarta Bay and to pump the flood waters out of this retention basin into Jakarta Bay. From the Jakarta Coastal Defense Strategy, a new design was made in 2013-2014, which we internally refer to the NCICD 1 phase, where you all know the big picture of the Garuda. You have seen it. And it is actually following that JCDS strategy, building a big outer sea dike. But why did it evolve in such a big project? Because the instructions that were given to the engineers was that it should not cost the Indonesian coffin 1 penny or 1 rupiah. It should be financed by Jakarta. And because there are many other problems to solve in Indonesia, so it was said, let Jakarta pay for its own flood protection measures. So the way to solve it was to actually reclaim a lot of land. And of course, land reclamation is very lucrative. And that resulted in a design like you see here with the Garuda, the national symbol of Indonesia, and a lot of land reclamation. But the price tag reached almost $40 billion. And that was also because some of the backlayed developments like sewage and waste treatment, pipe water supply were also put under the price or the price tag of this project. So that was the strategy defined in 2014. But let's look at what happened with this strategy. In 2016, President Jokowi asked his ministers, what shall we do with this project? Because everybody was getting impatient, floods were still occurring. And he asked his ministers, should we proceed with the construction of the Big Garuda NCICD project or not? But then what was said by his ministers is, well, actually, this plan did not look into all to the environmental implications. What is the effect of building a wall around in Jakarta Bay and lowering the level of in Jakarta Bay and lowering by that way the level in the rivers like the Cengkring Drain and the Banjing Canal Barat. It would mean that there is fresh water in Jakarta Bay and that the mangroves would disappear. It also means that you have a closed dike, that the fishermen cannot go out, that they lose fishing grounds. And the plan had not been discussed well with other neighboring provinces. And, well, it has all kinds of negative effects. Another issue was that the plan for NCICD, the NCICD 1, did not look at how to stop the land subsidence. So you can imagine that if land subsidence is not stopped, that even this plan would not be a sustainable solution for the long term. Because with 5-6 meters of land subsidence, this plan would have to be adapted again in 2018. So it was not a sustainable solution. Well, let's have a look at the historic overview of different ideas. We had the Jakarta Coastal Defense Strategy of 2012, the first updated strategy for the coastal floods, showing the picture that I already showed. Then we have the Garuda Plan. And after this decree of President Jokowi, Bapanas was actually asked to make an update. And they updated the master plan. And they did a very good job, in fact. In a very short time, they came up with an alternative plan, which is shown here, which actually looks a little bit like the first phase of JCDS, where they proposed to build dikes around the new reclamation areas. And for the longer term, they would fully close the areas between the land reclamations for the longer term. But, well, when the team that started NCICD 2 arrived, the team, reviewed these plans and saw that, well, the plan had some deficiencies in the hydraulic calculations, and they also applied some very optimistic land subsidence scenarios. So it was thought that this plan could also not be the solution, but both plans have very interesting ideas, and these ideas actually resulted in a new strategy, the Integrated Flood Strategy Plan of 2019-2020, which I will explain you a little bit more in detail. That plan came about with a few issues that were considered the main challenges So how can we reduce water pollution? If you close Jakarta Bay, it will be one big septic tank, and you would also have no access to the sea and fishing grounds. Building a dike around Jakarta also means that the numerous cables and pipelines that go outside have to be replaced. The environmental consideration, how to increase the mangroves or how to avoid the destruction of mangroves. These were very important concerns of all the stakeholders that were asked their opinion. And this process took place from 2017 until 2020. You see already the kind of image of the new plan that came out. This new strategy actually was a result of a study to different alternatives. The base case alternative one was also building a similar kind of dike as with the Garuda, the base case, and alternative two with a few center polders. And here you see an open sea dike, an adaptive approach. And here you see an alternative that was developed by Bappenas, by Indonesian experts, and an architect, which is the Waduk Lapas Pantai. Actually, they proposed to build a big seawall around in Jakarta Bay to lower the level with 5 meters and to develop these areas and to have connections from the sea to the ports and the fishing ports. And the idea was also that this reservoir can be used for the drinking water supply, future drinking water supply of Jakarta. But, well, there is of course a risk, because if you lower the water level in Jakarta Bay with 5 meters, and you have a lot of new industries and housing, what will happen if a tsunami attacks this river, or coastal protection, or if an earthquake destroys one of these dikes or connections? This is very unstable. You see that the bottom of Jakarta Bay is like yogurt. It's very difficult to construct a stable construction in Jakarta Bay. So this was actually also referred as a non-viable solution. But this is the new solution, and it actually proves, based on the roadmap studies that we did on how to stop land subsidence and when it can be stopped, we saw that if land subsidence can be stopped in 2030, 2040, that the complete closure of Jakarta Bay would not be necessary. And the idea was to build a new east-west connection, a transport connection, a toll road, with open connections and bridges. And the effect will be that you reduce the wave impact on the coastal protection system of Jakarta. And like I said, if land subsidence would be stopped by 2040, that solution could be enough. And the price tag was no longer 40 billion, it was about between 5 and 8 billion dollars, depending on some assumptions that were made, but a lot cheaper. Here you see an image of that solution. You don't see 17 land reclamations anymore. Why? Because in 2017, we had a new governor, Governor Anies, which was not very fond of land reclamations. So we were not, it was not allowed to assume 17 land reclamations. You know the discussions on these land reclamations. So a few land reclamations, the ones that had already been implemented in the eastern part or the western part, and a few new ones that were government plans would still be allowed. And you see here that these new land reclamations are partly served for the costing of this new initiative. And a lot of new developments were actually integrated in this plan. So a new cruise port, ocean parks, pilot projects, a national fishery center, and a toll road, very important part of the, also to make for the business case of this whole new plan. And this is actually the plan that was finalized in 2020. Unfortunately, decision making still is ongoing on this plan, but it is the latest strategy. Here you see actually the timing of this project and what it would mean for the flood safety. And so you see that the current flood safety levels, which are based on a kind of return period of 10 years, would go up for the coastal protection up to 1,000 years. And depending on the measures and the tipping points, it would stay above the 1,000 years return period. So a considerable improvement for the coastal flooding. Now, we see very interesting monitoring results quite recently. In 2018, a Jakar project started, and they did new monitoring, INSA monitoring, satellite monitoring, and these are the results, which actually show that the land subsidence rates in North Jakarta have reduced considerably. These results still have to be confirmed. That is not confirmed by all parties, so they have not been validated by ITIP Bandung, for example. But it shows that the land subsidence rates have slowed down, and that they are in fluid now, not 20 centimeters anymore, but around 9 centimeters a year. So that is a very good news. And of course, we were very interested to see what could be the reason. If you look at measures that have been taken the last decades, you see a few developments, economic developments, and a few measures that were taken. You see the Asian monetary crisis, which had an effect on industrial development and also on groundwater abstractions. And you see also that around 2010, a very important measure was taken to allow the increase of minimum wages of industrial workers. And that actually had a big impact on industrial development. A lot of industries moved out from Jakarta with very high wages to cheaper areas like Pekalongan, to Semarang, Brebes, etc. And you see that from 2010 on, the land subsidence problems worsened a lot in the eastern parts of Java, and fortunately also a governor decree on the recycling of water was taken. So these measures had an impact on the total abstraction of groundwater, and that is seen as possible causing this reduction of land subsidence. Now the question is, will NCICD, the NCICD 2, reduce all the flooding, or will it only reduce coastal flooding? But if so, what will happen with the pluvial flooding and the fluvial flooding? The rain-induced flooding in Jakarta and in the upstream areas of Jakarta. So now if we have a look at the rainfall events and the flooding events in 2013, in January 2020, and the whole of Jakarta was flooded, you see that this was happened on December 1 and the 1st of January 2020. You see here the locations of very high concentrated rainfall. So this is another type of flooding. It's fluvial flooding, it's pluvial flooding, and it's not related to coastal flooding. So if you look at the capacities of the drainage system and what happens, It's 377 millimeters of rainfall in 5 hours. And in February 2020, 54 millimeters in 4 hours. This kind of exceptional situations are still occurring and also used to occur. It's difficult to attribute it to climate change. This is extreme situations which can happen. But you see that Jakarta is absolutely not prepared for this kind of events. We calculated that there is about a capacity gap of more than 1,000 cubic meters per second. And this approached a return period of about 400 years, for example, of rainfall. And you can never design a drainage system of the city based on a return period of 400 years. In the Netherlands, it's about 10 years at maximum. So in that case, you have to take other measures, evacuate, early warning, etc., etc. But you all know the discussions that actually took place between the Minister of Public Works, Pak Basuki, and the governor of Jakarta, Governor Anies. One said we need to normalize the rivers, and the other said no, we need to naturalize the rivers. So who is true? Actually, you see here a picture of Jakarta, and naturalization of river means that you widen the rivers, that you give space to the rivers, like this river. But if you already look at the problems that the province of Jakarta had to resettle people, to raise the dikes along the Ciliwung, you can imagine that it is a tremendous task to have naturalization of rivers in the downstream area of Jakarta. It is still possible in the upstream part of Jakarta. So they actually were both rights, but they should have said, well, naturalization in the upstream part and normalization, which means that you actually build dikes that withstand the floods that can happen in the lower part. And so that was the discussion in 2020. So based on this flood, we see that several measures still have to be taken. Building polers with retention areas and pumping stations, the polers that were designed already by NEDECO, that still have to be finalized, but now with very big pumping stations. And to reduce the capacity of these pumping stations, you need storage capacity. That has not been implemented yet. The improvement of the river channel capacity, so the normalization, naturalization of the rivers, to take measures also upstream of Jakarta, has still to be done. The development of the coastal embankment still has to be done, and to build a good, proper flood management information system, a good, reliable early warning system that still has to be worked on, are some of the measures that are no regret, that will have to take place in any case. But let's look at the developments in Japan. You see here actually a picture from Tokyo. Because raising these walls along the Ciliwung means that you have water levels behind the dikes, which are several meters higher than the houses along in Jakarta. So this was also the case in Tokyo, where you had very high walls that would protect the areas, but that also means that the rivers were normalized, but they were not naturalized. So Tokyo did something to densify the city, to build a lot of high-rise buildings on these very big dikes. So these were super levees of several hundreds of meters. And that was possible because, like I said, a lot of low-rise buildings were changed into high-rise buildings, and that gave actually space to the river. So this is the image you see in Tokyo. Similar situation at Jakarta, but you see here a cross profile of Tokyo with very high water levels in different rivers. And this is one of these rivers. It's almost a natural river that has enough space where you can actually apply nature-based solutions to reduce the floods. But to implement these measures in Jakarta would require massive resettlements, a tremendous urban planning effort, and also bridging the gap between river management plans and implementation of all these measures, a long-term urban planning of more with a vision of more than 20-30 years to integrate urban design with flood risk management, a very close cooperation between the Ministry of Public Works and the province of Jakarta. And this cooperation is sometimes a challenge. You also need enforcement of zoning and working with rivers in areas where space is limited. So this is a massive challenge, of course, but we see this as the only long-term solution to reduce the flooding, not the coastal flooding, but also the fluvial and the pluvial flooding of Jakarta. So you see that NCICD solves the coastal flooding, but there is still a lot to be done to also apply the upstream, downstream strategies and to come to an integrated flood resilience design of Jakarta. Thank you very much for this, for your attention, and I'm looking forward to your questions.
Thank you very much, Peter. There's a lot of information you've shown. I mean, an incredible array. I mean, the data that's behind that is just fantastic. I don't get to see any questions on the chat, but I suspect there may be one or two in the room here. In that last list, I missed the issue of water supply, because hands up anybody who gets their water here from a pipe that comes from the government. Who gets water from a pipe? Who gets it from a well? Well. Big problem. Yeah. So, any comment further on that? Because I don't see the list.
I could have told you everything that was done to come to this new roadmap for the mitigation of landslides. And actually, also a roadmap for the water supply of Jakarta was made to see if we really want to implement all the piping water supply projects in Jakarta, how much water will be needed, where to get it from, and how fast this could be achieved. So we did actually the drinking water communities and the responsible institutions for drinking water supply cooperated with us in making this roadmap for the mitigation of land subsidence. And actually they showed, based on their current plans, that water distribution, the pipe water supply of Jakarta could be finished by 2025. Why would it take such a long time? Well, water has to come from the Karian River, for example, and all these water transport facilities take a lot of time because of all the licensing issues. And well, this is the main worry. And of course, there were discussions on if there is enough water supply for the longer term of Jakarta. So there is a lot of misconception there. You saw that the plan of the Waduk Lapas Pantai was actually justified partly to collect water for Jakarta for the future, assuming that there would be no water enough for the longer term in Jakarta. But actually, we had already done an cheese study, so looking at the water availability in all the rivers east and west of Jakarta, which actually showed that there is enough water for Jakarta for the longer term. And that was even based on the assumption that that all the projects, of course, were implemented, but this takes time. And so that we actually assume that if water supply can be ready by 2025, it could take 10 years for the land subsidence to more or less drastically reduce. So by 2035, land subsidence could be reduced, but we now already see that it is slowing down because of the effects that I showed. But it is a very good question that what has been proposed in terms of water supply. So it was actually part of the study. I just did not show all these slides, but it is part of the plan. Yes.
You can probably read the first question very short. The second question is coming from one of our previous ICE members here, Engfin. Graduated here in Indonesia, went to London also, now working in Hong Kong. But if you'd like to, if you can read those to yourself, then please could you?
Well, there's a question from Matthew Everson. How is the current integrated flood strategy being funded? It is it's public funding, but also partly private funding from making use of the land reclamations. So it is a combined public-private funding scheme. And the second question from Engineer Finn.
Actually, this is a very good question because we've heard these rumours that Engfin mentions here. So it is the selection of areas that are going to receive the floods. Yes, very good question. Is it true?
Well, I presume that what you mean with select the areas to receive the flood for each flooding period in a rotational basis, actually these retention basins that were designed in the NEDECO plan have not been all implemented. So there are certain pumping stations planned in North Jakarta where retention areas have to be combined with these pumping stations. And these areas still have to be identified. In that sense, it will cost a lot of money to resettle the people from these areas, but these will be fixed places where it will not be on a rotational basis. And actually the idea for the future is to connect all these polders so that the different pumping stations can help each other in case there's a torrential rainfall event in East Jakarta, that the pumps in Western Jakarta and Fluid can also help the pumping stations. So these polders will be connected. But I think there is not the intention to divide or distribute the flooding areas in Jakarta on a rotational basis. So now the east has suffered enough. Let's now put the floods to the western part.
I think it was also about the expensive housing areas being avoided. I mean, this was a sort of rumor we used to hear. But,
well, no, I don't think that is really the case. And you see very close to Fluid also that the richest people are actually suffering most from the landslides because they cannot see that close to the houses anymore because of the walls. So I think that is not really. And there is a question also from Waga Asanka.
No question yet. He says, "Let me know." Any questions from the floor? Yes, go. And Martin, filter.
You might come in front, and then the others can hear also.
So, long-term urban planning in 20 to 30 years is a challenge in every country in the world because of the political situations. And here we're thinking about building a new capital. Do you think that is against conflict with the chances of this scheme going?
The question.
I did not really hear.
Well, because there's a plan for new capital. So concentrate on the new capital, forget about this problem. Yeah?
Of course, it is a challenge for the Indonesian government to finance the new developments in Nusantara, Kalimantan, and also solve the flooding issues in Jakarta. But like it was said before, Jakarta should solve its own problems, and these new developments will not be financed, of course, in Nusantara, will not be financed by Jakarta, but will be financed from the national budget. So it is different sources of funding. To take away a misconception on this new city is that because of the land subsidence, the government would give up on Jakarta and look for a better place in Kalimantan. Of course, that is not the case. The idea of the ministries is to alleviate the pressure, not only on the floods, but also on the traffic, the pollution, air pollution, etc. So it is to alleviate and also to spread the influence of government to other areas. But no, I think it is not competing for funding.
So before we have one, but Martin, would you like to ask your question as well?
You showed a slide earlier that showed land subsidence across Jakarta. I couldn't quite pick up. It looked like there were a few different positions where those measures were taken. I didn't quite pick up where they were. My experience is ground conditions are a lot better in the south than in the north. I'm guessing the worst measurements were right up the north. And I guess my question was going to be, you propose part of the reason for it.
This is the distribution of land subsidence in Jakarta.
Slide that had a graph of measurements.
I think it's the next slide.
This. Because this is one of the locations, Damogot, which is in the western part. So we also made this kind of similar scenario calculations for two other locations in the middle, Sunter, and the other one in the east of Jakarta. On places where we actually had all the information to make this kind of modeling calculations.
I guess one of my questions was going to be, I mean, the Jakarta government certainly has been, in the last 10, 15 years, increasingly requiring groundwater recharging in all developments. Whether you think that might be part of it, I think that was part of what you were saying, is what you think is part of the reason for it. I was really going to ask, you might have already partly answered this in what you already said, but is there less, I mean, someone asked the question, who pumps water and who gets the farm, and everyone, including me, said, but particularly in the north, is there a reduction in pumping water out of the ground? Whether it be for domestic use, I mean, you might have been saying industrial use, definitely less, but I'm not sure how much industrial there was right north there.
There was quite a lot. There was quite a lot, yeah.
Right. Okay, so that's really where the difference is.
It's industrial, but also the high-rise buildings, big government buildings that are also using groundwater. And the problem is actually not the small shallow wells that you are using. Because if you look at the geology of Jakarta, it's an alluvial geology, so which means that there is a lot of clay layers, sandy layers, and it is also not one straight pattern of clay layers. So it's a kind of mixture between sandy ridges and clay. And the reason why Jakarta is subsiding is because the hydraulic heads groundwater pressure in these sandy alluvial aquifers is reducing, and the neighboring water, groundwater in the clay layers is also reducing the pressure. And that leads to compaction of the clay layers. If you look at the geology of Jakarta, so the recharge areas for the north of Jakarta are actually situated much more to the south. And rainfall that falls in North Jakarta will only stay in the first aquifer. So actually the shallow wells do not really have, the wells up to 20 or 30 meters, do not really have an impact on the land subsidence. It is mostly the deep groundwater abstractions from 200 to 300 meters in the second or third aquifer in Jakarta that has an impact. That is also shown from the extensometer measurements that have been done. It shows that at these levels, the subsidence is strongest, and not. So actually, you could say the groundwater from households could still be continued, but if you say it could still be continued, then everybody says that my groundwater abstraction will continue. And that is also why it is such a problem, because most government buildings have pipe water connections and they have wells, but they still use the well because the water quality is better, it's for free. So it's a very wicked problem. And there is also a perda which actually says that groundwater, that government buildings can freely use groundwater. It's defined by regulations at the provincial level. And we said you should really abolish that perda because nobody will care. And you see that actually this whole issue of governance is the most difficult for DKI Jakarta to actually solve. And you see that they have been very lucky taking measures, for example, that never intended to be effective for groundwater, reducing groundwater abstraction by increasing the wages of industrial workers. That actually had a very big effect. So fortunately that happened. Costs.
We have got one more question. Yes. Very
Thank you, Peter. You described 15 years with more Jakarta problems, the risk for all the people in North Jakarta. A lot of technical issues, and discussion always ends on a polder here or something to drink them up at another place. For me, the big picture still is, after 50 years, we don't have an agreed plan. Yeah. There's nothing available on the internet that is newer than this Garuda of 2014. There's no politician in Indonesia to be found who cares about what's happening here. There are no NGOs talking about this issue. Why are we still talking about this? Why are we so alone in this issue? Who is needed to take a decision? What needs to be done to improve the situation? Because land subsidence continues. You get more and more people in Jakarta. There is no urban development plan. It's a mess. Yeah. What needs to be done? Nothing technical solutions.
What's the answer to that? I think it's
Now we are coming to the key issue, which is politics. And of course, you're right. There has been no update of the 1973 integrated master plan. And even the plan of the IFSP 2020 that we worked on is still at is a plan developed by Minister of Public Works, but there is no consensus yet between the different ministries if this is the course or not. And you see that, the plan from the Ministry of Bapanas, which is the Waduk Lapas Pantai, for example, I showed it, is the preferred strategy according to Bapanas. So Bapanas and Ministry of Public Works are not on the same page. And if there is no consensus, there is no decision making in Indonesia. And you know, all the parties have to agree. The Eastern Banjir Canal constructed after the floods in 2007, I showed it, was built in 3 years. Why? Everybody was convinced about the need and the urgency to stop it, these floods. And that is why decision-making was able to be done in a very short time, and the construction, once actually the consensus is there, the implementation capacity is enormous. So I respect the Indonesian abilities to build this kind of big infrastructural works, but it is how to come to consensus on these issues. That is why, yeah, there are all kinds of reasons why, well, by the way, Coach, we are both from the Netherlands, and sometimes decision-making on these big infrastructure projects is also cumbersome in the Netherlands. It can take very long, big infrastructure projects. So we sometimes demand Indonesians to take a decision in 3 years, where we normally would take 8 years, because it is a project that we have to be financed by some parties that has to come with a result in 3 years. But it doesn't mean that we can always influence decision-making at a high political level with the funding. It should come, probably a big flood is needed to come to a kind of sense of urgency to implement the next stage. But that is the difficult part, actually. I hope that you agree, that you...
We'll just try and fit in. I hope the room is happy. There are a couple left here, so can we get this gentleman to ask this question? Or yeah.
Hello.
It's hello. Hello. Please ask your question. Yeah.
Yeah. Okay. My question, actually, I have one question and one suggestion. The first question is, will the future reclamation should face the risk of land subsidence? Because now, according to your explanation, the land subsidence is about 0.1 meter per year. So that may be a huge amount for land reclamation. That is the first question. Then the second is the rainfall-based flooding. So was there any study was done about having a detention tank at the upstream, the south side of the Jakarta, and later on we can use that water for hydropower or such kind of activity, because the most severe rainfall is about 4 to 5 hours. So, and also the river capacity is exceeding only 1,000 plus cubic meters per second. So if we can retain those water at very upstream of the rivers, so the flooding can be reduced. That's all.
Okay. So your question is the effect of the land reclamations on the land subsidence.
Yes.
Okay. Well, indeed, land reclamations add to the weight of the soil above the clay layers. So it indeed adds to the land subsidence, but not as much as the groundwater abstractions. If you quantify it, it has a lesser, smaller effect than the groundwater abstractions. And with regards to the possibility to use upstream water for hydropower or for other purposes, the naturalization of the rivers of the upstream area of Jakarta is certainly an issue that should be studied, and it would be worthwhile because it would delay the floods, the flood waters, and on the other hand also increase the recharge, groundwater recharge in the northern part or in the southern part of the river basin. So that would be a positive development, yes. But like I said, the upstream downstream approach, the fully integrated approach, still has to be developed.
Okay, thank you.
And I see also a question about the JLA project.
Chris Hannon is one of our committee members.
Indeed, it was to connect the east and the west channels, and also the dredging of the drainage channels. and to rehabilitate retention basins in 5 new ones. Well, the retention basins have not all been constructed yet, but we have done some simulations of the effect of the dredging of the lower end of the rivers, and that actually had a very positive effect. And a much better effect than, for example, the lowering of the water levels in Jakarta Bay, because the whole NCICD 1 project was based on the lowering of water levels with 2 meters in Jakarta Bay, and it was thought to have a very positive effect on the rivers, the Jakar drain and the Banjir Canal Barat and Eastern Banjir Canal, because these are too big actually to pump the water out and to build retention basins. So these always had to stay open. But we saw that the dredging and the accumulation, the sedimentation of the lower parts of these rivers was a very important factor of the high water levels in the upstream areas. So that project, the JCDS project, was quite effective. Yes.
Last question.
Yeah.
Last question from Ivan Haryono.
So to avoid reclamations, we have considered building 2 or 3 layers of dike, like the Afsluit dike and the Marco Water dike in the Netherlands. Is water pollution really an impossible issue to solve? So if you look at the Ciliwung River, it's one of the most polluted rivers in the world. So if you want to use these end-of-pipe kind quality waters for the drinking water supply of Jakarta, I think you better use from other areas. I think it will be a very expensive situation to use to first let the water flow into these almost septic tanks and then clean it up to drinking water quality. It's better to bring the water, fresher water from other river basins, or to use the water from the upstream areas where it is still of reasonable quality. So I think we dealt with all the questions now.
Wonderful, wonderful.
Yeah.
So I think it's time for you to have a rest, Peter.
To have a beer.
You have a beer, have a curry. I'd like to say again, thank you very much for presenting so much incredible data. A real big topic for people in the Jakarta. Just to say for those who've listened in on Zoom, thank you very much. I hope you've got all the information. I think it's come through very well. Maybe the next meeting we may have a few more people in the room here, because it's really good here at the moment. We don't know what you're missing. A few more people here and just as many on Zoom. So I can see the hybrid approach lasting for a little while yet, but we're so happy to be together again and meet each other again and have a curry and a few beers and whatever it is. I'd like to bring the event to a close, which means we'll shut down the Zoom system now. Thank you all again for attending, both remotely and here. Chance to talk to each other now, which is half the purpose of these meetings. So Peter, again, thank you so much for your
It was a pleasure.
Great. Okay, thank you very much. Organizing committee over here, who will now shut down Zoom.
Once again, thank you, Peter Letitre, for your excellent presentation. And thank you also to Phil Woodmansey, David Mee, and Michael Dobie for guiding the session. Ladies and gentlemen, we have now reached the end of our event. Once again, thank you for your participation. We hope we can see you at the next event. At last, good evening and stay healthy, everyone. Thank you.